Good morning, good afternoon, good evening, depending where you're joining us from. We are here to reveal another capture the flag solution. This time it's for CTF number 27, correct?
Yep.
And this is sort of a fix to another CTF that Itzik will talk about both for a second. But what I like really about this one is that this is a demonstration how when you patch something you don't really resolve it. So this is something that I've seen happen often and often when a pen tester comes and tells the developer you've got an issue here. The developer comes, fixes that problem, and then the pen tester comes again and again overrides that patch. That's what happens when you don't solve the root cause. Um, but that's enough from my end. I'll pass it along to Itzik. And just to remind you guys, this is part of the Wizer Secure Code training. We have a public version of our CTS. This is sort of what we're going over right now. And it's under wizer-ctf.com. You can go in and play and join the community. And you can try to solve those challenges on your own. So, with that said, Itzik, I'll let you present the CTF, and then we're going to talk about the solution and the key takeaways.
Right. Thank you, Gabby. So yeah, as you mentioned, this is kind of like a phase two or a level two, whatever you want to call it, of an existing challenge. We had challenge number 17 was about a privacy policy viewer. And we've created another one where the lesson here is that, the pen tester, as Gabby mentioned, probably came back and said, hey, this is vulnerable. You can do this or add a dot dot slash and go to another file. It was a directory traversal. So the developer actually fixed it, but they didn't fix it well enough because they don't understand the core issue and the core problem or the scope of the problem. Okay. So in this CTF, you are number 27. You are required to read the content of the passwd file, which demonstrate that you can go and look at files that you're not supposed to. The app here is a privacy policy viewer. It's fairly easy. You have a URL, and you can provide, a company name like Wizer, and you get the privacy policy based on the company name. Okay, so here's the privacy policy for Wizer. It's just there, right? It's a file. And so how is it done? There's a React, in this case Next.js code that reads the parameter, reads the company name, and reads the company profile. If we look at the endpoint, okay, what it does, it actually goes to a folder. So there's actually a folder on the drive under privacy policies, and there's the company name that we're looking for. However, the developer realized that if someone in the company name uses dot dot slash multiple times, they can get to another file. So they patched it and added a replace all for this occurrence of dot dot slash.
Cool. So they saw the issue, they understood the issue, and this is why I love these examples because you can see that the developers thought about the security implication here. So they addressed it, and we see that often and often again where people are, they just don't have the attacker mindset. They do understand sort of the problem and they try to address it, but not in a meaningful way. So let's see how the attacker now bypasses. How does he traverse back even though you replace the dot dot slash? Let's show us how to do that. How can you bypass this security control?
Absolutely. So in this challenge number 27, okay, what you can do is we've done that times and times before. Okay, so we're tricking the replace function where what we're doing is we're doing like we're adding dot slash, which will replace this part, right, and would leave us with dot dot slash. So just like a couple of items we had in the past, replace is not, or replace all is not a good solution. So when you do that, it doesn't even it's not even important how many times you go, as long as it's enough times. You go up, 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 up. You can go multiple times more than needed. You'll still get to the root, and then etc passwd. You hit send, and you can get partial part of your passwd. So it actually reads your passwd.
Yeah. This is clever. This is, this is when you understand like how developers thinks, and when you see how they solve how, what security control they put in. And like you said, replace is such a bad one because you just, put something before, something after, and the replace just moves the middle part, and then it becomes the basically in this case the dot slash.
Right.
So yeah,
Yeah.
this
So
is a
there's a lot of takeaways that some of them we already talked about in the past, but are super important. So for challenge number 27, there's the write up, and in the write up you can see a walkthrough of the code that we talked about. But then there is the most important part, the key takeaways. And what's important here is two things, right? Avoid supplying file name directly from user inputs. In this case, to prevent a directory traversal, you don't want to ever provide a file name. You can provide an ID that goes to a database, brings a file name or something like that, translation table, hash table, some IDs, but actually directly taking a file name and finding it on the drive, you can manipulate it and you can do a lot of stuff with it, and it's not a good idea altogether. And then search replace, we talked about it, are very risky. When you replace one character, it's stronger, but still not necessarily good enough. But when you replace a string of multiple letters, there's always a bypass. There's always a way to do, couple of times the same thing, or just cut and paste and do what we've done back then with JavaScript and so forth. Here, it's just dot dot slash. You get to the same point by replacing. So very, very problematic. And I would say the last thing is, you can always assume that if you found something like that, instead of replacing it, just stop the process, right? So instead of finding dot dot slash and replacing it to remediate it, assume that someone is trying to trick you and stop the process. It will never get to anywhere. Because if you found dot dot slash, you could say, someone is trying to trick me, stop the process.
yeah. So I think, and that goes probably along for like everything, not just the replace. Like if you in the code, if you get to a point where you think you're being tricked in some way or another, just stop the process. It's sort of like phishing. If you see that the email address is potentially, there's spelling mistakes, don't click. Don't just copy the URL and just replace that, character. Just like
Try to fix it. Yeah.
try to fix it. Just like don't do it. Right?
Yeah.
You're being tricked.
Don't trick you. You don't want to be there. You don't want to be there. That's not a good place to be.
Yeah. And I remember there was another CTF, one of the first ones. I think it was like even Zero Papers, like the first one, where it said the developers was trying to look for JavaScript. I think you mentioned that. And then by that's how they sort of figured out if there's an XSS or anything like that, just by looking for the JavaScript keyword. And then the solution was to write JavaScript, script, and then when you replace JavaScript with empty, the Java and the script combine, and you've got JavaScript, and you can run your script.
Yeah,
so
very similar.
Very similar to this. This was like probably the CTF number 1, I think, right?
It's not number 1; it's number 8, but it's one of the first ones. So
yeah,
I think one of the key things here are, developers sometimes, they write the code, it's already working, and then you come back to them with a vulnerability, and they're saying, okay, I want to change the bare minimum and fix the problem. And sometimes that bare minimum is not good enough.
Yeah,
because it fixes one problem. So when you see a security vulnerability, first research the scope. Here, if you understand the scope, then what do I mean by scope is what are the different things that could happen altogether, not only one specific scenario that someone gave you. What are the different things that could happen, and what is the best practice to avoid it, right? In this case, I would completely replace the idea of a company name with something like a company ID, and make sure that ID is in a good format. Then you can never sneak in go back to any other folder or any other characters, right?
Cool. So Itzik, thank you very much. We're going to meet again next week for another CTF reveal. And for all of you out there, if you want to try this CTF out, if you want to practice it or send it to your team, once again, wizer-ctf.com. It's open. You can play as a guest or you can sign up. Both work. And if you want to be in the leaderboard and you solve the CTF, you can put in your name and then you'll show up in the leaderboard. We have a very active community. You can ask them questions if you need help with some of the CTFs that we haven't revealed yet. You can see that in the Discord. So, like I said, it's very active. And yeah, hopefully you will. Honestly, this is one of the best ways to teach developers how to write secure code. You really want them to learn how attackers think, because, like I said here, yes, they addressed the issue, but they addressed it in the wrong way, and that just happens so often. Anyways, Itzik, thank you very much, and we'll see you all next week. Bye
Thank
bye.
you. Bye bye.